This is Carsten OZ9 Alpha Alpha Radio with another video on some new features in SimpleCalc. SimpleCalc, as shown here, is used for predicting sun noise levels. It can calculate your receive chains and other things, download solar flux values and so on. And it has also a noise measure window or measure noise window. Normally, when you have it connected to a sound card, you will see a trace here that shows the audio level. You can, in different ways, show it. You can make averages, and you can specify the width in seconds of the screen and so on. A lot of things you can do. Some of the new features is if you right-click, you can actually load and save data from the noise window. In my case, I have prepared some data from my 4.8 meter dish on 23 centimeters, measuring sun noise and termination resistor noise. And if I press load file, I have this file here. I will open that, and this will show you the data. Let me see if I can find it in here. Yeah, I was zoomed in. Sorry. This is data that is saved some days ago. You can see it is around 5 minutes worth of data or so, and this is taken live. Let me clear the markers. This is the data as it looked right at when I did it. The only difference from live data and this here is the recorded data has a blue line. So if I connected it to the radio now and started using data again, it would actually just get in from the right. So the next line segments would be read as normal instead. So you can mix both saved and real live data. Only the color will tell you the difference. Now, a couple of new features in the noise window has to do with the markers and stuff. First thing is if you hover your mouse top of the line, the noise, you see some data. You see the level minus 53.23 dB, and you see the azimuth and elevation of the moon and the sun at the time the data was recorded, which in my case was April 15th at around 14:55 local time. So if I go over here and hover here, if I can, you can see the time has changed. So this is just to tell you that all timestamps and stuff in here are actually from the time where the data was recorded. Now, next thing we can do. This is data that I collected. This is terminating the LNA into a terminating resistor, a 50 ohm resistor, and this is sun noise. And the trace over here is what I consider cold sky at my place. Now, I want to see, how much sun noise I see, and I want to see the terminating resistor. So in my case, I will right-click here, and I will place a reference marker. It will just put a marker down, the star-shaped blue, and the level and the moon and sun position at that time. I can then go up on top of the sun noise, right-click, and I can say place delta marker. It will show the level, and it will show that the reference it is referring to is the 56.98. This is this guy down here. You see, you get a a star with with more arms on. I don't know what the name is. And you see the moon and sun position and the time. And you see the delta of plus 16.51 dB. This is the delta between the reference you place down here and this measurement. So I'm seeing 16.51 dB of sun noise. Now I can go and place another marker. Right click again, place delta marker. You see this delta marker is with the same reference, the 56.98 dB, and the delta between those two are 7.62 dB. Okay, and again you see sun and moon positions, which is not important as you're measuring the terminating resistor, but yeah, anyway. So, and I can go down here and I can place yet another delta marker, and I will see a delta of plus 0.18. This is because that this area here was not my cold sky. It was on the way up measuring the sun noise. If you want to remove any marker, just click on the text and the marker will disappear. Let's we can place this one again. Now you can also place a new reference marker. Let's say that I want this here to be my reference. So I place reference marker. This is not easy to see. Let me put it here. Now you see I got a new reference marker at minus 56.54. Now the old reference marker stays and the values here stays because these delta markers was with the old reference marker at 56.98. So that doesn't change anything. But this guy is a new reference marker. So I could put, let's say I want to see the delta, this one. The delta is minus 0.36. And this is with the new reference marker. So if you place a reference marker, all delta markers after this will use that as a reference until you place a new reference marker. So you can always make a new reference marker and do some delta markers based on that one. As soon as you define a new reference marker, you can't refer to the old one anymore, but the data that are here will stay there, so they're not lost. Can't place new delta markers with that one as a reference. I hope it makes sense. And you can clear all the markers, and as you saw, we can load data. And when you load the data from a file, or when you save data to a file, all the markers you have on the screen will be saved and loaded. And you can, as I showed, you can then remove them if you want and place new markers and save that as a file. The last thing is that if you point anywhere on the trace, if you left click, you will place those small red stars here. They are just, arbitrary markers that will show the level, sun and moon position, and the time. They are not referenced to anything, so they are just absolute markers, and you can place as many of those as you want. Again, click on them and you will remove them as the other markers. So this is a quick this was a quick look on the markers, and you can of course change the level. You can even zoom using the scroll wheel of your mouse if you want to zoom in and so on. Everything is like normal. It's the sun noise. This little guy here is what I call a persistent line. You can just remove it. It is just a ruler you can put anywhere you want, and it will show the level it's placed at. And if you have incoming data from your sound card, you can actually you can see the difference from the incoming data to this guy. You will see this number here change. Right now, the incoming data is 0. I have nothing connected, so the difference is plus 58.02 dB. Now, if I had a signal coming in at minus 55, it will say it would tell me plus 3 dB here instead, and so on. This is just a line you can place and use whatever purpose you want. Yeah, that was it. More information on my website, www.moonbounce.dk, and look for SimpleCalc there. Bye for now.